We've just talked about three different ways of adding cases to a data set. So we talked about concatenating, appending, and interleaving. SPSS calls this adding cases as opposed to adding variables. So now we're going to talk about this other activity, which is to add variables to make a data set wider as opposed to longer. Let's start out with two data sets, and we'll call data set 1, 1, and then the second one is going to be called 2. Both of these data sets have a common key. Okay, so a key is a variable that uniquely identifies a record, and in this case it's going to be this customer ID. And then I've got another variable in data set 1, which is something, just X, whatever X is. It could be number of purchases last year or something like that. And just to keep things simple, I made X equal to ID. So notice that data set 1 has information for 4 customers in it. Data set 2 also has this customer ID variable, but it has a different variable Y. So what we'd like to be able to do is to set these data sets beside each other. So instead of stacking them the way we did with appending or concatenating or interleaving, we want to put them next to each other so that we would know the values of both X and Y for each customer ID. Now there's 4 different ways that we can do this. And I'm going to start using the terms from relational database theory, which we're going to cover in a couple weeks. These 4 different ways of joining them are referred to as the full outer join, the inner join, the left join, and the right join. So let's start out with how these things produce different results, and then we'll look at the syntax for how we achieve this. So what's a full outer join? Well, a full outer join is going to take all records in both data sets and just put them next to each other. So here are the results of a full outer join. What you're going to notice is that there is a record for customer 4, and since there is no record for customer 4 in data set 2, the value of Y is therefore missing. We also have a record for customer 5. 5 doesn't exist in data set 1, therefore the value of X is missing. So that's a full outer join where we have a record for every primary key in either data set, and if it's missing from the other ones, the variables are just set to missing. Now, an inner join it's more the intersection of these data sets as opposed to the union. We're going to use those terms slightly differently later, but let's see what we get with an inner join. So an inner join retains records that are only from both files. So notice customer 4 and 5 do not appear in the inner join result. It just stops with customer 3. What about a left join? Well, the left join is going to take the left file, which I've had as data set 1, and any time that the left file contributes a record, the left join will have a record in the output. So notice customer 4 is there, customer 5 is deleted since that record is not in data set 2. You can almost guess what the right join is going to be then. If 2 is my right data set, notice we have a record for customer 5 but no record for customer 4. So how do we achieve these things in SAS? Well, the syntax is going to be similar to what we had, but we're going to use a merge statement instead of a set statement. So we're going to make a new data set. Let's call it the full outer data set. And instead of setting 1 and 2, we're now going to merge it. Remember when we did our interleave, we set A and B by a variable. Here we're going to merge them, and we need to specify the value of the keyed variable, which in this case is ID. So that's what we're going to do our match on. So whenever the customer IDs from data sets 1 and 2 match up, then we combine them. And this is all you have to do. to get the full outer join. Now, how do we get all these inner and left and right joins? The answer is we need to do two things. We need to add an in equals statement to the end of each of these data sets, and we also need to specify an if-then statement. So let's talk about the inner join. I've added a statement in equals A to the data set 1. Now, what does this do? Well, A is going to be something called a SAS temporary variable. SAS temporary variables do not exist in the final data set. They only exist while SAS is doing the data step processing, and then once we exit the data step, this variable A is going to vanish. Okay, so that's what a temporary variable is. What does in equals do? Well, in equals tells SAS to assign the value true assign the value true to the variable A whenever this data set contributes a record. So when the record is in the data set 1, variable A is going to be true, otherwise it's going to be false. This variable A can be any valid SAS name as long as you're not already using it in the data set. Now I'm going to do the same thing for data set 2. We're going to attach an in equals B statement here. So B is just a variable name that I happen to choose. I like to use A and B. You could call them anything you want. But A and B are often used in the SAS manuals as well. All right, so B then is going to take the value true whenever the data set 2 contributes a record, false otherwise. Now, remember I said we have to do two things. We have to add the in equals, then we have an if-then. So this if-then says if a record is in both A and in B, then you're going to keep it. Otherwise, delete it. And so that's how we achieve this inner join. So notice when we reach this record 4, well, B is then false since that is no longer in data set 2. It's not in data set 2. So the if A and B fails and the record is deleted. Likewise, when it comes to this customer ID number 5, A is then false since data set 1 does not contribute a record. So it fails there as well. The only times that it is true, and both of A and B are true, are for those first 3 records where both files contribute. Now if you understand that, it should be fairly straightforward to do a left or right join. So with a left join, all we're going to do is change the if-then statement to if A. We don't care about B. So notice here, if file 1 contributes a record, we're going to keep it. So 4 stays, 5 goes. 1 point, I just copied this. This in equals B is not really necessary since it's not used at all in the program. I just left it there for consistency's sake. Now to do a right join, we're just going to change the if then to if B, and that's only going to keep records that are in file 2. So 4 is gone, 5 stays, since file 2, the right file here, is contributing a record. So those are the 4 types of joins. Let's now talk about an example that illustrates a very realistic situation where you're going to have to do either a left or a right join. So I've made some very small data sets to represent realistic data sets that you encounter quite often. So let's say we get a data set from the US Census. The US Census is conducted every 10 years. They release all their data to companies for their use and other organizations. They release it at different levels. Let's say for the sake of this example, we have the 5-digit zip code, and we have some demographic information that was collected by the census for each zip code. Let's just say the average number of years of education of people living in that zip code. So Here's some data. 60201 is a zip code, 17 years of education, 60626, 11 years, and so forth. All right. Now I'm at some company. I have a household file. This is my household file. I've got some customer name. Now in real life I'd have an address and probably a customer ID. But for the sake of this example, we'll just say I have a name. I know where the customer lives in terms of a 5-digit zip code. And then I've got maybe monetary value, so the amount this customer spent last year. Now what I'd like to do is to merge in the census data. So I'd know the education. Maybe I want to use this in a predictive model. I want to find out how education predicts monetary value. It could be a very important variable if I'm going to try to do some new customer acquisition. So I've read in the census data and I've read in the household data. Let's sort both of them by zip code. So I need to sort by zip because that's going to be the variable that I'm keyed on. And then I am going to merge them. So I'll make a brand new data set called both. We're going to merge these by zip. Notice since I don't have any in equals statements at this point, I'm going to do a full outer join. So if we go look at the result, we get the full outer join. So notice Julie lives in 60203. However, that zip code's missing from my census data for some reason. Therefore, I don't know the average education of people in that zip code, and therefore I have no value of education for Julie. Notice also that I don't have any customers living in 60626. So since we're doing a full outer join, SAS keeps this as a record, so we don't have any name associated with that, no dollars, but we do know the average education of people living in that zip code. Now this is probably undesirable. This record in particular, it has no use to us. We probably want to keep Julie in there since she's a customer, it's just that we don't know her education. So what we really need to do is a left join. So I only want to keep records in this merged data set where I have a record coming from my household file. How do we do that? Well, we have to add an in equals statement. So let's just add an in equals a to the household data set. Forget census. We don't care about a right join of any sort. And then I just need to add an if-then. So I need to do those two things, add an in equal and then an appropriate if-then statement, and we get the result that we wanted. You should now try these your turn exercises, which will give you some additional practice on match merging. This is a very important topic.